Okay, the next step in Lab 1 is to take the design that we created in EDAPlayground and import all those design files into Vivado so that we can target the design to the Basis 3 board. Okay, so the setup for this is you've watched the video about box, so you need to set up something like I have here. I have some main folder called Labs. I click on that. And then I have two folders here, one for Lab 1. When we do subsequent labs, we have a folder for each one. And then I have a folder for constraint files. So if I look into here, I have these constraint files that I downloaded from Canvas. So you need to set this up like that, create a file folder called constraint files, or whatever name that you want. And then download these files that let Vivado know how to make the signal connections on the Basis 3 board. So we're going to be using, in this particular lab, we're going to be using button down, button left, button right, button up, so you'll need those. We don't use the system clock yet, but we'll use the LEDs, the 7-signal display, and the switches. So download all those. All right, the next thing you need to do is within Lab 1, create a folder called Sources. All right, so from there, what I've done, I've already set this up, is I exported EDAPlayground to a zip file. So I unzipped that and copied all the files from that zip file into this space. Okay, so I've got all my SV files. There's some extra stuff that I got, but I can just ignore that. All right, so I've got all the files set up. I'm ready to go. I'm ready to import this into Vivado. Okay, so from there, you can search for Vivado. I've already got this up and running, but you search, you launch this app, and it takes a while to come up, so I have it already, set up and going. All right, so from there, what we need to do is we need to create a new project. All right, so create project, and then hit next. And what you'll find then is it sets up a project directory name. I just go with that usually. I'd already had a project 1, so this one starts with 2. But you get to choose this name. I just went with the default. The next thing I want you to check here is that, oh, look it, there are no spaces anywhere in here. All right, you want to make sure anywhere in the path there are no spaces, because otherwise this will jump up and bite you. Vivado has a bug in it. It can't handle spaces in the file names or the path names very well. Sometimes it works, sometimes it doesn't. And when it doesn't work, it's hard to find that error. So make sure there's no spaces anywhere in this path name. Happens to someone every semester, so don't let it be you. Okay, next. The thing that you're going to always have for this setting is RTL project, do not specify the sources at this time. We're going to load those sources in just a second. So click on that. And the next thing it's going to want to do is it's going to want you to choose the target. So you can press this parts tab or the board tab. We're looking for the board. And so I click into this search window and BAS, Basis 3 board. Click somewhere in here to where this is highlighted. Don't click the actual link here because that just takes you to documentation on the board. I guarantee you will do that at some point. But there we go. We got this ready and we hit next. All right. So we're going to have a new RTL project, project 2. That's fine. It's got the Basis 3 board in here. We're ready to go. All right. So it's creating this project. This takes a while. So I'm going to edit this part out. The waiting part's going to get edited out, and we'll be back in a second. Okay, at this point, it's finally initialized the project, and what we're ready to do is to add sources and constraint files to the project. Okay, so we're going to start with the design sources. So I'm going to click this Add Sources button. And there's 3 different types of things we can add. I want to do design sources right now, the SV files that we created for our digital design in EDAPlayground. Okay, so I hit next, and then I hit add files, and I'm going to search the directory structure. So I'm looking here, I want lab 1 files, I want sources, and I'm going to look for all the SV files. SV stands for System Verilog, by the way. And so I hit the control button here so I can select just the design files. And notice I skipped over 2 files. I skipped over design.sv and testbench.sv. Well, if you recall, design.sv just had the includes. All right, so Vivado, it's a big time professional piece of software. It can actually look at your code and deduce what is the hierarchy of your design. And so it doesn't need these include files like EDAPlayground does. All right, so I've selected all the design files and I hit OK. All right, and then I hit finish. All right, so it's adding those sources. Okay, so that's done. So what I'd like you to do is explore this a little bit. Notice that it knows, you can click on the hierarchy here and you can take a look at what Vivado thinks, and we see the wrapper on the very top, and then coming off of the wrapper is the actual top part of our design, and then you can see underneath that are the individual modules that make up the top. So if you'll go back, I want you to know this workflow. You have a top design that calls modules and gets things set up the way you want for your digital design. Then you put in a wrapper to map the board signals to your design, and that's on the very top. Okay, so that looks right. All right, so the next thing I want to do is add the test bench. Okay, that's a simulation source. All right, so next, add files. And we didn't talk about the test bench in this lab. We're going to take that up in lab 2. But it's the way you make your design simulate. You have to tell it to do something. You've got the design there, but effectively you've got to operate the design. That's what the test bench is doing. It's simulating button presses and letting us take a look. Did the display number come up the way we expected? Okay, so I'm going to add that and hit finish. All right, and it looks like that's updating. And I just want you to know it's important to keep straight the design sources from the simulation sources. If I click this button here, it tells me that I have the test demo wrapper that uses all these other things. It uses part of the design files, and so that's why it shows up in the hierarchy. But the very top here is the test file that we use for our simulation. Okay, so we've got the design, we've got the test bench in there. The next thing we need are the constraint files. Okay, so it's got a place for that, and so click next. This is a straightforward part, but it's a straightforward step to do, but it's necessary to get everything set up correctly on the boards. Okay, so we've downloaded these. We we incorporate what we need from these constraint files. We didn't use the center button. We just use, I'm going to hit the control button here. So I can select all these. We use down, left, right, up, LEDs, 7 segments, and switches. All right, so we just incorporate what you need, and we finish that. Okay, so those are into our system, and the next thing we're going to do is we're going to run through this workflow. Okay, so the typical steps in the workflow is to first simulate the circuit to make sure it's doing what you expect. So we already have a test bench in there, so we can run this simulation. Press this button. It takes a little while for it to calculate everything. I'll be back in just a second. Okay, it looks like our simulation is complete. And what happens at the end is it pulls up the test bench file. It knew that was the simulation you were wanting to run because there was only one simulation in the project. Okay, so from there, you click on the Untitled tab here. You can even break that out. All right, to get a bigger window. And you can auto scale this by hitting this button. And we'll talk more about this window when we get to test benches, but this is showing me that everything looks like it's working right. If you see anything red or blue, you'll need to see me in the lab because something is not working right. All right, so this is looking good. You can tell where I'm simulating button presses and getting results showing on the 7-segment display and the LEDs. Okay, so what I want you to do at this point is take a screenshot of this, and we can use that to incorporate that into your lab report. So be sure and take a screenshot at this step. Okay, so once you're done with that, let's close this and go to the next part of the workflow. The next part of the workflow is to run a synthesis where Vivado is trying to take your design and create a hardware model for it. All right, so this hardware model is at this point independent of the board. The next section where you implement that, it uses the knowledge of the board to map that design onto the board. Okay, so we'll first run the synthesis. This takes a while, so we'll wait for it and then I'll get back with you. Okay, so at this point it's come back and it's ready to go to the next step, which is to run the implementation. So click OK. All right, and again, this takes a little while, so pause the video and we'll get back with you in just a second. Okay, it's finished this step, so the next thing we do is we generate the bit stream. I like to think of the bit stream as the actual binary file that lets the board know what connections to make to wire up all the necessary connections to build our digital design. So we're going to generate the bit stream. That takes a while as well, so we'll get that started and I'll be back with you in a second, so just go ahead and pause the video. Okay, it looks like this step is complete, and so it's suggesting to open the implemented design, but what we need to do next is to open the hardware manager so that we can load this bit file to our board. So click this radio button, hit OK, and up comes the hardware manager. It didn't take too long. You may need to open the target, auto connect. I'm actually running this from my Mac using a virtual connection to a Windows machine in my office. And so this takes longer this way. So at that point it comes back and it says program the device. We can hit this and your design should, actually what happens is a window pops up that shows the path to the bit file. So notice that it ends in demo wrapper.bit. All right, that's the file we need to load to the board. So from here you just hit program and that does it. That moved your digital design to the board. All right, so from there you can just test it and see if it works. So hopefully you found this helpful. We're going to do this workflow lots of times in this lab. You'll get this down cold, so no worries there.